if I don't get the videos posted on our Schoology, you can always go to the YouTube page and look them up. So Caleb, sorry that you're not with us today. Hopefully you feel better soon. Did we make it all the way through 1210? We solved all these. We got to use it. Okay, that's what I thought. So using a graphing calculator is pretty easy. So we're going to go through this kind of quickly. So get out your graphing calculator, or if you need one, come grab one. So if we are going to solve by using the graphing calculator, all we're actually going to do is plot both of these as two different functions in the calculator, and then use our second of trace and find their intersection point. So if IPvo will ever open up, so put both of those as functions. So your first one, negative x plus 5, and your second one, negative x squared plus 4x plus 1. So your y equals, clear out anything that's there. Any questions?
Is this the homework?
No, this is the end of 1210. The only thing we hadn't really gotten to is solving it by graphing, but it's really easy, so it should only take us a couple minutes. So then graph both of these. I like to zoom standard to begin with. So before I graph, I go to zoom and I hit 6, and then it will take me to my graph. From there, if I can't see it, I can change my window. But a lot of times, because the people who wrote the textbook know that you're operating in a standard window, they either make it match the window or they intentionally make it not. Here, obviously, they made it to match the window. Now, go to second trace, which is your calculate. We want to go to intersect, so just hit 5. Now again, you are on one of the curves. If I hit up or down, I will switch which function I'm on. But it doesn't matter. My first, notice at the bottom it's saying first curve. This is not left, right, guess. This is first curve, guess a point, second curve, guess a point, and then guess a point. So notice, just watch up here for a second. It says first curve, I hit X. Then it says second curve, I'm on the parabola now, not the line. So still as close as possible to the intersection, hit enter. Then it says guess, all of these points should be at the same point. So you should just be hitting enter, enter, enter for first curve, second curve, and guess. We come out with 1, 4. Then I second trace again for intersect, move over to the other, and again, once I get the point closest to it, I just enter, enter, enter.
And we can use this on like tests and stuff?
Yeah, if you are allowed to use a graphing calculator, then yes.
Is there any tests that we won't be able to use graphing calculator on?
I think there's a section of the air test that you're not allowed to use any calculator on.
Will we have to graph stuff?
I don't know. I don't write the air test.
You should write one.
Yeah.
Yeah, except then I couldn't be a teacher.
Why not?
Because those are two different things. So, trying to got it, set that up on your own. Try to get those real quick. Look up here if you need help. Remember that if you have a function that starts out with a negative that is different than the minus, the negative symbol is different than the minus. It even looks different when you type it in. It's a little bit higher and it's a little bit smaller.
Can you go back to the y equals? Where's that? Thank you. Oh, okay. Never mind.
They're just on the paper. So then I go to my graph. Second trace 5 for intersect. Go over whichever side you want. Enter, enter, enter. Negative 2, 2.
I got that.
And second trace 5. Over to the next one. Enter, enter, enter. And positive 1, negative 1. Any questions on that process? Oh, wait. Never mind. Wait.
The second one, how did you get the one? I got this one. How did you get the one?
I had to again hit second trace and rerun it. So I go and do intersect again. It's asking me first curve again, so I move my point over to where it needs to be, then enter, enter, enter. You gotta make sure you hit your enter 3 times because it won't generate the intersection until you've made your first curve, second curve, and a guess. Yeah.
What's the point of separating those?
Something that your calculator's doing. It's like taking an average of the function. It's some math that happens that we don't care about.
Like, is there any situation where you don't just go enter, enter, enter?
Not if you have 2 systems intersecting like this, no. Like, I've not encountered a situation where it would be different. Because if you're finding an intersection point, so the only difference would be if you're so zoomed in that moving a pixel literally shifts whether you're at the intersection or not. So technically, they're 2 different points. Because if I zoom way in, like you asked the question, so now I gotta answer it. Which is not a bad thing. But, so if I zoom way in, let's Z-box on this. So here's my intersection, right? Now, even this zoomed in, I don't think I'm far enough, so I'm gonna Z-box again. Just to try to get you to see what it's actually doing.
How far would it let you go?
I mean, you can zoom in infinitely. It's just going to end up looking like straight lines. Alright, so when I'm looking for my intersection, my first curve, I'm on the line. So technically the point that I'm on is on the line. This, I'm now technically on the parabola, or vice versa, I forget which is which. I think my first one was actually the parabola, and now this is the line. So this is technically a different point. Unless my screen has so lined up that that pixel location is the physical same x and y coordinates. So when we're talking about being the same point, on the screen it's the same pixel. But on the function, it's probably not technically the same exact point until I do my guess and it generates this average thing and it brings my points as close together as possible and finds the point. Does that make sense?
Yeah.
So like we're hitting enter, enter, enter. It's the same point, quote unquote, but it's not actually. It's switching which function it's on, and it's really probably switching location minorly, but it just then brings them together, averages it out, and finds that one point where they intersect. So you don't need to think that deep about it, but that's what's actually happening. All right, any other questions from 1210? All right, let's look at 1211. So now all these little things that we've talked about with the focus, the directrix, and all the little names that we've talked about but haven't really talked about why. There is a point on your parabola where if you had a lens, this would be the focus point where all the light is directed together. So if you were trying to project the light outward, that would be where you'd want the light bulb to sit to project the light forward. If you were trying to capture the light, like say you were trying to light a fire like your Tom Hanks Castaway on a desert island, he would want the light coming inward to his parabola. Say this was like a flashlight or a headlight from, whatever, there's a car headlight or something. You would want whatever you were trying to catch on fire to be right at that focus point because that's where all the light would be focused together and that would be the hottest point. So, we don't really need to answer this question. We'll come back to this once we know a little bit more about this. But so we have these 2 points, we have this 1 point called a focus and then a line called the directrix. Now the distance here, my smarting is turned off. The distance between the parabola and the focus is the same as the distance between the parabola and the directrix. So while smarting loads this, where my circle is spinning right now, that distance is the same as this distance. So the further that my focus gets up the parabola, the further that my directrix gets away from the parabola. Now, okay, well, what is the directrix? What's the point? The directrix is the line that is equidistant from the parabola as to the distance from the parabola to the focus. So, this doesn't quite make sense at first, but give me a second. Is Smarting gone now? Yes. Alright. You generate. So, we'll look at how we find the focus. So, this angle right in here has the same relationship as this angle right there, and this line has the same length as this line. So these relationships that we're setting up, let me orient this really quick. Sorry, my morning classes did not need the smartboard. So those functions or those equations on your notes are very important. So these right here, I would put a star off to the side next to them or something that indicates that these are going to be very important as we move forward. So here, I have one done out for you. We have the parabola, and with vertex at the origin, focus is 0, 2. So we know nothing about the parabola, except it hasn't been shifted, because its vertex is at the origin. And its focus is 2 units up. By the way, just talking about a horizontal parabola, notice that to get a horizontal parabola, all you do is flip-flop your x and your y. So instead of y equals something x squared, for a horizontal parabola, x equals something y squared. So that's all we do to get horizontal versus vertical. And we'll come back and look at these formulas as we need them. We know that the standard form of our parabola is actually going to be 1 over 4c x squared. When you're given the vertex at 0, 0, so notice this is no shift, no horizontal or vertical shift. If we have a shift, my equation becomes a lot more complicated. But we're going to start easy. If there's no shift, I can actually derive the equation of my parabola using this formula. So I plug in my c value, which here my c value is 2, because c comes from my focus. And we get our equation 1/8 x squared.
What is this equation for?
That is your equation for the parabola now. So this parabola is the function 1/8 x squared.
So we would use this
to derive the function, like to derive the equation of the parabola if we know the focus. If we know the equation, we can derive the focus. So it's kind of like...
so the focus helps us make the equation.
Mm-hmm. Because the focus is really what we care about from the parabola. So when we start working with curves and we work with objects that make parabolas or parabolic relationships, that focus is the point that matters. Because like when you take your car to the shop and they install headlights, or if you have a bulb blown or whatever, if they do it right, there are 2 adjuster knobs at least on the back that adjust the angle up and down and how far in or out the bulb is of the casing. So you have your headlight casing and your bulb can shift forward and it can shift backwards. If your bulb is too far backwards or too far forwards, your headlight is either going to bounce like this over and over and over again, or it's going to angle way far out and throw really wide. Either way, that's not what you want. You want your headlights in a beam forward. So you want your light to come out into the parabola and bounce to come out, as opposed to bouncing back and forth over and over again. If your bulb's in the wrong place, you're not going to see down the road. You put your bulb at that focus, you get the whole throw of your headlights. So let's try one of these on our own. Weird. Yeah, I don't know. Oh, sorry. This should have been at the top of this page. So the vertex, focus, and directrix of this parabola. So now if we're given the equation So go ahead and write this down in the open space on the back. We have y equals negative 1/12 x squared. By this not having a b value and not having a c value, what's up?
You okay?
Yeah, I'm fine. I just wanted you to know I didn't screw anything up.
I was awfully sensitive, Mr. Hudson.
What? Mr. Shurig made it seem like I had double
I did
booked
not.
myself.
I just asked the question.
And I had not double booked myself. Somebody else booked me. I seen just like, I gotta leave class here early. I got scheduled to be in a meeting, and he made it this morning seem like I had double booked myself. And he was like, Mr. Hudson, if you had checked to see if you were available, this wouldn't happen. Nobody asked me if I was available. They said, hey, there's a meeting at 1 o'clock. We need you. I have class at 1 o'clock. So they double booked me. So I emailed him to let him know,
So we
hey,
have 7 minutes?
Huh?
So we have 7 minutes?
No, I gotta be down there about 10 after. So we'll get through enough of this so you guys can work on your practice.
So we have 7 minutes.
You know, Mr. Hudson, why do they do this to you?
I don't know.
It's
So,
like they don't even
since-
count your feelings.
Since we know that there's no B and no C value here, what's the first thing that we immediately know? We don't have to calculate anything. All we have to do is have our brains turned on. It asks for vertex, focus, and directrix. Do I know anything about these guys yet? I'd have to calculate, right? Brian?
The vertex would be 0, 0.
Yeah, my vertex has to be 0, 0 because I haven't shifted at all. Then to find my focus, because my vertex is at 0, 0, my focus, if you go back up to the equations on the front page, which are now on my TV, but you guys have it probably more easily accessible just from the front page, the value of my focus comes from, bless you, the coefficient to my x squared. Michelle? So we know that, I'm going to shift this off to the side because we know it, we don't really need it right now. This is equal to 1 over 4c x squared. So what must c be to make that happen? Ooh, close. -3. So c equals -3, which tells me that my focus, or where that bulb would need to go, or whatever we're talking about in that situation, would be at 0, -3, because this parabola is pointing down. So the focus of the parabola is actually 3 below the vertex.
Hey, Mike.
Yeah.
Right on the board, but freeze right so I can panel you around.
Okay. Freeze right.
Yeah, you guys don't move. Don't be stupid here.
So if we then, I can talk while I'm frozen. If we then want to find the directrix, we said the directrix is that distance between the vertex and the focus, but on the opposite side of the parabola. We're good now. So how far is between the focus and the vertex? 3. That distance is 3, so that's a change of 3. So my directrix is going to be at the line of y equal to 3. Because it's that continuous line out. Yeah.
If, since I'm going to Coach Noted, how much money would you guys give for every pizza?
20%. Whatever you spend. Pizzas there are under $10. Yeah, so a couple bucks per person.
Pretty
So
rad.
every single person that goes.
Well, you got
Um,
$2.
Sorry, I just had a thought. And then you asked me that question.
I'm sorry.
It's okay. Yeah, I'm not sure. Not right at the moment. I appreciate that.
We're just thinking of you.
So, now we take what they give me and derive other information. So now, all we're actually given is 2 points. All they tell me is, hey, you've got a headlight, or a flashlight, or whatever it is that you've got, And the distance between the base of the parabola, the vertex, and the focus point is 1.5, or more so negative 1.5, but there's a span of 1.5 there. So I can figure out my directrix, but I don't actually need to. Brian, give Michelle the last one.
Is it the answer? Okay, the answer.
I mean, we are looking for the equation.
Oh, okay. Well, then it would be y equals 1 over 4c, but the c would be 1.5, so you can do 6. It's genius. I know. And then x squared.
My c would be what?
6.
No, my
No,
c.
your c would be 1.5, but negative 1.
Ah, negative. Dude, that's completely, it changes everything.
Yeah,
That changes
why?
whether your parabola points up or points down.
It's like the headlights pointing into your car.
Yeah, that, like, if you made that design flaw, you have your
Yourself on
headlights
the
pointing
road.
towards the driver, as opposed to down the road. So it'd be like, oh, it's getting dark outside. Headlight, ah! Like, that would be a bad design.
Unless you're Beyonce.
Alright, negative 1/6 x squared, and that's it. Because there's no horizontal, no vertical shift. No shift at all. So now we went from barely understanding why we use a parabola to when only given 2 points, we can derive the function that quickly. Because those 2 points, that distance between them, tells you how wide or how narrow the parabola is. If this has a fraction for the coefficient, is it wider or narrower? No, you need to know where the focus is in order to, well, knowing one of them will let you know the other one. So if you know neither of them, you cannot just pull one out of nowhere. Does that make sense? Now we can derive it, like we can use a function like we had back on the first page, but you'd have to do some math to know that. Calvin?
The denominator of the fraction times the x squared is made.
What? The what?
The denominator of the parent the fraction in the parent function.
Okay. Has what?
My name.
Has your name. I'm so confused. I know you're trying to make a joke, but I don't think I get
The
it.
denominator.
Yeah, 6.
In the parent.
Oh, God.
4 minus 4c. His last name's 4c.
I think you have a bright future in making dad jokes.
Dude, you should have math gradient.
So now, kind of to answer Michelle's question, if you're given the vertex at the origin and the directrix, okay, we still know that change, the distance between them, is 1.25 right now. But since the directrix is at the positive, we know that my focus will be at the negative, but be careful. This gives you the image to reference, but when your directrix is given as an x equals, that tells we have a horizontal parabola. So my directrix is a vertical line. My focus will be in here. Finding the focus is not that hard. It asks me to find the equation. So if I wanted to find the focus, I would just go 1.25 that direction. And my focus, we could say, is at negative 1.25, 0. Because it's a horizontal parabola, these switch places. Because I have to go to an x and then a y of 0. We then use that c value, because if you go back to the first page, now this is c, and we set up the function 1 over 4c, y squared, and we get negative 1/5 y squared.
Well, for the equation, since it's horizontal, we use the same one to just switch that.
We did. X equals 1 over 4c y squared.
Oh
as opposed to y equals the 1 over 4c x squared. Yep. Yeah, yeah, we got it. Yep. This one solved out for us. So we didn't really have to try too hard. I know this stuff's complicated, so I leave a solved out for you solution so you can always reference back to it. So now we're given the equation. Now we got to work backwards and derive everything. This x equals 0.75, y squared is equal to 1 over 4c y squared. So this is really 3/4. So what we can see from here is 3/4 equals 1 over 4c. We can cross multiply here if that helps us. We get 12c equals 4. Careful here. C can't be 3 because this would be 1/12. C's a third, not 3. Because remember, division by a fraction actually multiplies by the reciprocal. So being that this is an x equals, my focus point then, my c comes first. So I have 1/3, comma 0. Questions on why that's happening? My c value over here is 1/3. And because it's a horizontal parabola, we know it comes at the focus gives me the x value instead of the y value. We good?
Yes. Wait, I'm confused on how you got the second where you got 3/4 equals.
Because if I wait here, just change 0.75 to 3/4. I just canceled out the y squared on both sides.
Okay.
Other questions? Okay, so then Directrix is always on the opposite side of the parabola. We also already know, what do we know about our vertex? Yeah, it's 0, 0. There's no horizontal, no vertical shift. So if my focus is a third on the positive side, that tells me that my directrix, now if this is a horizontal parabola, it's pointing to the right, which means that my directrix will be a vertical line, so it's going to be x equals -1/3. This is supposed to say x equals -5 y squared.
No.
This?
No, it's not.
Oh, the directrix. Sorry, I thought it was saying with the equation of. Yeah, so now we know the directrix. Oh, it gives you the vertex of the origin. There we go. That's the part that we would have been missing. So if we know vertex at origin, we know directrix at 5 we know the distance between them is just 5 If the vertex is at the origin, that tells me that my focus has to be 5 away from that. And if this is negative, that one's positive. Michelle?
If the parabola is not
This tells me that it's a horizontal. I guess I don't need a colon there, I would just need a period. Yeah, my focus then is at 5 halves 0. Because I know it's a horizontal, I'm going to have x equals 1 over 4c y squared. So 4 times 520 divided by 2, I get 10. 1 over 10. And that's it. Any questions? So this is where this is getting used. And actually there's this really new, really sweet new solar panel that is a flower. I don't know if anyone's ever seen this thing, but it has a little base. It's probably the size of one of these shelf things, but it's shorter. And it literally, when the sun comes out, it pops open these doors, it stands itself up, flips the top part up, and then unfolds into a big flower petal. So take like one of those Japanese fans that opens up, like the, you know what I'm talking about? Yes,
Yeah.
maybe. So each of those petals is a solar panel, and it follows the sun as the sun moves. So it's one of the first smart solar panels. It can generate 40% more electricity than a standard solar panel because it can follow the angle of the sun. That sort of technology is put into use, but here, this doesn't need to follow the angle of the sun because the parabola utilizes the fact that as the sun moves, regardless of how it hits the parabola, it mirrors into the receptor. So the only issue is this is all, depending on where these actually are, sometimes these are all mirrors and then there's a solar receptor in the middle. Sometimes those are all solar panels, so regardless of the angle of the sun, they can receive some of the light, even if not all of it. Question?
Oh, I was just gonna say, I saw something that looked like one of those on a Boys Life magazine, and
Yeah.
you can make a solar-powered hot dog maker.
Yeah. My buddy who hiked the AT had a solar-powered like battery charger pack thing. So when he would stop, he'd solar-power charge a battery pack, and that's how he would charge his cell phone and everything
Oh,
else.
that's rad.
I
Yeah.
have one of those. It's on the inside.
That's
I
not good.
have it.
So, this solar panel that we're designing, let's say we're designing it, we want to make it 8 feet wide with a depth of 2 feet. So that tells me about my parabola. I can have a depth of 2 feet at 8 feet wide. How far from the vertex is the focus, and what is the focal length? So, our focus, they're saying, and it's hard because this 8 feet is written on top of it, but this is our focus. We know that we have a span of 8 feet, and it has a depth or height or whatever you want to say of 2 feet. Kyle?
How do we know that that's the focus?
Sorry.
So wouldn't it just give us the answer?
No, so if I said that I misspoke, that's the point that we've been given. So that's the a point on the axis of symmetry. It might be the focus, but it's going to be on that line somewhere. So we start to try to draw this. Go away. So we have two choices. We can either make it start at the origin and go up from there, or we can make the origin that center point that we know of. So because my graph has some negative and some positive, I'd probably make the origin that center point. So I'd start your parabola 2 down. Now if it's 8 feet wide, what's another point that we would know then to place on? My solutions would be positive 4 and negative 4. Okay. Now we could, at the same time, imagine that we have another graph here that would be centered with a vertex at 0, and then it would just be shifted up everything 2 points. So you can, at the same time, think of what this graph would be if we just focused it, or sorry, centered it at the vertex. We could make the same thing. And then that'd be a little bit of an easier function to understand. But the only difference will be a -2 tossed in there. What do we know? Okay. Brian?
It's wider than just a normal x.
It's wider than our parent function, so my coefficient is going to be some kind of fraction. This, because I have a 504 meeting to get to, this is why I wasn't pushing for us to get into that problem too deep, is going to be a good place to let that sit for the day. We will pick these up tomorrow, but all I want you guys to get through are the ones that seem manageable. If it doesn't seem to make sense, skip it for the current time. We will pick up this lesson tomorrow, we'll wrap this lesson tomorrow, and then the rest of this will make sense. For tonight, just do which ones of these are manageable. Can I trust you guys to be cool in here for the next 5 minutes until it's time you leave?
Can you definitely
No.
The mission here.
I don't think it would help, actually.
I think it looks like low.
That was so funny. I laughed so hard. Yeah, I'm an awful person.